In the previous activity, we created a circuit with an LED and a resistor connected to a Raspberry Pi Pico. We didn't get too much into detail of how LEDs and resistors work, and that's what we're going to cover in this session. We're going to start with a basic of electricity. So we have electricity, which is referred to as direct current, and we've got electricity referred to as alternating current. The electricity that you use in your homes and in industrial applications is mainly alternating current. The reason for using alternating current is that it can be transmitted over long distances without losses in power. Direct current is what you'll typically find from batteries. So the batteries that you put into remote controls and other devices is supplied in the form of direct current. With direct current, we often see the signs plus and minus on batteries and various other devices which use direct current. Whereas where you use alternating current, you'll see reference to neutral and live, as well as earth. For the purposes of the projects we're going to do, we're using direct current. So having said that, it's important to note that various components will be polarized, meaning you have to connect certain bits to positive and certain bits to negative. In the case of physical computing, you won't always hear reference to negative, but you will hear reference to ground. Ground generally is connected to the negative terminal of your power source. So if you had a battery in a circuit, the negative would connect to your ground. Let's start with an overview of LEDs. So as I mentioned previously, an LED is a light emitting diode. I've got different LEDs here with me. The first thing about LEDs, if you remember, is that one leg is longer than the other. And the long leg is going to connect to a positive or a GP pin. So if you are connecting it to a battery circuit, your long leg is going to go to your positive and your short leg to your negative. Connecting to a Raspberry Pi or another microcontroller, short leg is going to ground and the long leg is going to your GP or GPIO pin. To test whether an LED is working or not, you need what we call a multimeter. On your multimeter, you will have a setting for testing diodes, and you'll see a symbol for a diode there. So you turn your knob to point at that symbol for your diode, and using your probes, you connect the red to the long leg and the black to the short leg. And you can see the resistor lights up and there's a faint orange light there. Let's move on to resistors. The point of using resistors in circuits is to reduce the amount of current that flows through a component. So you can connect an LED directly to a Raspberry Pi, or you can connect it directly to a battery. The risk, though, is that if too much current flows through this, it's going to blow. And so we use resistors to protect LEDs as well as other components from having too much current flowing through them. Now, if you look at the resistors, our resistors are marked with a resistance. So that says 10K, and then it's got that funny symbol, and that means 10 kilo ohms. When you look at your resistors as well, there are strips that go around the resistor and they have different colors. The strips determine the resistance of your resistor. The strips on this set of resistors, which is 2,2 kilo ohms, is different from the colors on this one, which is 470 ohms. You will have resistors with 4 bands, and then you will have resistors with 5 and some even with 6. In the next activity, we're going to connect different resistors to LEDs on a breadboard and connect that to a Raspberry Pi Pico to show you how different resistances determine the amount of light coming from an LED.